Hi, my name is Gordon Moretsky, and I'm the Center Manager for the Walker Advanced Manufacturing and Innovation Center here at Niagara College. We are part of the research division at Niagara College, and our subject of interest is advanced manufacturing. That's a really broad topic, but we started our center on three basic technologies: reverse engineering, precision metrology, and additive manufacturing. And I'm looking forward to giving you a tour right now. So if you just follow me. So in this section of the lab, we have our computer stations, our 3D CAD stations, and we have some of our precision metrology reverse engineering stations here. Here we have Brock. He's actually doing a live scan of a part from it's a water pump from a car, I think, right? And with this scan, he's scanning all the object points of that part into what's called a point cloud. It's not just a picture. There are thousands and thousands and thousands of points, sometimes millions of points, that define the object and the perimeter of that object. So there's lots of different uses for that. We use that in industry for quality control, for reverse engineering, for legacy parts, designing and modeling parts that don't have drawings anymore. And we'll take that data and import that into our CAD stations and use that as part of our 3D design. So here Jackie's working on something that we have scanned, we've reverse engineered, and we're modeling to make a new part. And this actual part was a different technology, metal casting, and we are designing for manufacturing to do this in a plastic print. The way we work with industry, and we're here to help industry, is we work with an industry partner, the person who needs the help. Then we have subject matter experts, dedicated researchers and faculty, and our lab technologists. And then we hire co-op students from our programs, mechanical, electrical, and even computer technology. They come work for us for a co-op term, and they get all kinds of experiences with different manufacturers, different companies, solving their problems, working on research projects. The things that you discover here are far beyond those three technologies that we talked about. When we do research projects, really anything of advanced manufacturing subject is on the table. Okay, this is an example of a research project that our students may work on. And this is a welding assembly for a customer for ours, and it's essentially a welding robot that we developed here to do a particular type of weld, which was previously done all by hand. And this is a typical type of research project we could work on. This room that we find ourselves in, we call as the tool room. And we do a lot of rapid prototyping, but some of the technologies that we use for rapid prototyping are our CNC router, which is over there. And the guys over here are working on our laser engraver cutter. And we can laser cut and engrave anything except metal materials there. So a lot of polycarbonates, wood products, and we use that for prototyping and actually some end products for our research projects. This side over here, this big guy is a big bath. And what this does is we put our printed materials in. When we 3D print something, it prints with support material to hold it up. And it's soluble with a certain chemical, and this chemical is in this bath, and we put it in there, and it dissolves the support material and yields the part that we actually want to have as an end result. This is our CNC machine. It's rather than additive manufacturing, which is what our 3D printing technologies are, this would be subtractive manufacturing, where we take away the stuff we don't want. In additive manufacturing, we put on the stuff that we want. This is our print room, our additive manufacturing lab. And this is where we have the big machines that print the big parts. And we do a bunch of different types of materials. This is our big Fortis 900 machine. It has a print envelope of 2 feet by 3 feet by 3 feet, I believe. It's like a giant oven. That's the platform of the size of parts that we can build. And some of the things we can print
this is the difference between your desktop machine and these professional machines is the material choice. So we can do our standard, ABS and ASA materials, but we can get into some really exotic materials. Like this material here is what's called Ultim. This is actually a print of a Formula car airfoil. So it's a part of a section of it. The exotic materials allow us to do a lot of exotic things. And in prototyping, it's a lot cheaper to print a part in plastic than it is to build a steel mold for something that you only have to make one of. And in the automotive side, for instance, we can print a part in Ultim and install it on a car for a long enough period of time before it fails, make a bunch of different tests and what-if analysis before we go to tools. So that's one application of it. We can save a lot of money on tooling costs. And then, of course, we can do a lot of really cool stuff with 3D printing. This is a bone matrix for growing bone on. Just some sample parts in printed ball bearing assembly. Different durometers of things, which is the different types of flexibility. And the geometries you can get in 3D printing are much different than perhaps some fixed geometries, subtractive manufacturing. So some pretty cool applications in 3D printing. So one of the topics of advanced manufacturing is the Internet of Things, Industry 4.0, and connecting the machines to our data centers and our accounting systems. And we're heavily involved in that. We're starting to get more and more work in that sort of area, doing more developmental type of work. And this section here is where we build the alpha and beta circuits to test those applications. So we'll build schematics of circuits. We'll connect those to the cloud. We have resources here in place to do the CAD/CAM on the circuit boards. And then here we can do a beta run of circuit boards for our client to use and then test in their field. This is a pick and place machine. And one of our guys just picked and placed a bunch of resistors that said hello on it. And there's our reflow oven. So once we've picked and placed the parts onto the circuit board, goes through our reflow oven and solders that automatically. Here's our hand station. So we have different types of soldering irons and desoldering stations, some test setups, microscopes. And so that is very much a part of what we do as well. So this is our computer-controlled coordinate measuring machine. And this is part of our reverse metrology, our precision measuring, and the Industry 4.0 applications that we have. So this machine takes very accurate measurements of manufactured parts. It compares the deviations between as designed and as manufactured. And that data can be used to either accept or reject parts or send them back for rework. And in addition, all that data gets imported into greater analysis. So the engineers and the designers can take a look at some pattern failures, perhaps get a long history of their parts that are being made, make improvements, and it's all about part of the data acquisition. So data is key here, and this machine helps us get that data from those parts. Okay, so this is a part under analysis. It's on the test bed. And we have a program that's going to touch point different positions of that part. This equipment, you can imagine, is very expensive. And we're here to help industry to introduce these technologies to them, to increase the skill levels of the students that come through here. And I should mention that all the students that are working here on their co-op terms, out of the mechanical programs, out of the electrical programs, electronic programs. And we even have people from the computer technology programs come and work for us on our co-ops. So it's a really cool place to work. So if you're in those programs, there's an opportunity here to apply and get a job here, just like any other co-op. But one of the benefits of working with research is you're exposed to a lot of different technologies. It's never the same every day, and you're often exposed to a lot of different industries So there's different levels of reverse metrology that we can do. We can do very, very tiny, precise things, and we can do very large campus-sized things. And this is a point cloud of a scan that we did through the Walker Advanced Manufacturing and Innovation Center. And those little balls are just little reference balls. And we've taken a number of scans and meshed those together in software so that we have a complete virtual representation of this facility. So here we're actually just walking through it. This can be the inside of the building, the outside of the building. There's a pile of different applications for this. We use this a lot in plant moves. For instance, a plant is moving from one location to another. They'll scan both spaces, and then they'll put the drops down and everything so that when those machines go in there, they're ready to go. And the plant move is a weekend instead of months, because typically what's been done is the machines get moved and they say, okay, now we need to connect them, and there's a lot of time. So a lot of pre-work can be done and keep the operation going. Lots of other applications. Like I said, we've got very small scanning abilities, medium scanning abilities, and large scanning abilities. So this can be even with drone imagery. It can all be meshed together. It's all cloud point data. So this is the strength of the software and the technology that we have here, and the skill of our students and our faculty and our industry experts. So we work with industry in a number of ways. We work with the industry partners, which are the manufacturers and the different businesses that we work with. And we bring a team to the table. We bring our research experts, our subject matter experts, our dedicated researchers, along with our lab technologists and technicians. As well, we can draw on faculty. And then part of the experiential learning experience is we hire co-op students. And the co-op students come from the co-op programs, the technology programs here at Niagara College. The mechanical, the electrical, and the electronic technology programs, and even the computer programs that we've hired co-op students here to work on different types of projects. So if you're part of that program and you're looking for a co-op, Research and Innovation has opportunities for you to apply for, and especially here at Walker Advanced Manufacturing and Innovation Center, we are looking for those people who are interested in working with a number of industry partners. If you come work with us, you'll have exposure to different technologies. And we're research, so some days we don't know what we're doing, but whatever we're doing is pretty cool usually.